in this video we're going to be talking about integration. All right, we're going to be going over different subtopics under integration: upper and lower limits, algebraic substitution, partial fractions, basically, things like that. All right, to the end that at the end of all of this we'll be able to solve questions on integration. Basically, the opposite of integration is differentiation. All right, so in order to have a very good knowledge on integration, it's very advisable that you have a standard knowledge on differentiation. All right, I think I made a few videos on differentiation in my previous video, so you can always check that out. All right, but let's get started with this. So like I mentioned, differentiation, or integration rather, is exactly the opposite of differentiation. All right, so now in differentiation, 2x to the power of 3 would be 6x to the power of 2, and that'd be your answer. All right, but in integration it's the opposite. So basically what we did to get this was we multiplied 3 by this, then we took 1 away from it. All right, that's exactly what we did. Okay, let's take this out. But for integration it's quite different, all right, in that you would add and then you divide. Remember, for differentiation you multiply and you minus the power, but you add to the power and then you divide, all right, to get your answer. All right, so this is how this would be. So if we want to integrate this would be 2x. Now you add 1 to this power, so that will be 3 plus 1, 4. Now whatever your power is, you now divide by that. Okay, then you have plus, you do the exact same thing here, 3x, you add 1 to this 2, so that will be 3, then you divide by 3. Okay, then we have 6, so that will be 6x, then you add 1 to the power. Now there's an imaginary 1 here, okay, so you add 1 to that, so that will be 2, then you divide by 2. All right, then we have plus 5. Now how exactly do we integrate constants? Well, the way we integrate constants is by adding an x. All right, but now it's 5 that is here, not 5x. Well, but if we put a 0 here, i.e. x to the power of 0, then it's the same thing as 5. So 5 and 5x to the power of 0 are the exact same thing, because x to the power of 0 is 1. This is basically saying 5 plus 1. All right, but remember, we need to add 1 to the power. We need to add 1 to the power. So 1 plus 0 would be 1. Then you divide by 1. We don't need to put that. All right, so now 2 would go here twice, so we'd have x to the power of 4 over 2. 3 would cancel out 3, then we have x to the power of 3. All right, 2 would cancel out 6, that would be 3. All right, so that would be 3x squared plus 5x. all right, now don't forget to put c. Now c is the representation of a constant that we do not know about. All right, c is the representation of that constant, because if you were differentiating this, all right, you would differentiate this and it would give you 2x to the power of 3. all right, if we try that, you basically multiply 4 excuse me, 4 by this power, that will be 4 multiplied by this. 2 would cancel out 2, then this remain 3, so that will be 2x to the power of 3. all right, I'm just trying to explain how you can differentiate and get back your answer. So if you're not sure about your answer, you can always differentiate these terms and it should give you back this. That's why having knowledge on differentiation is extremely important. All right, so now this c constant is here because if you differentiate this, it's going to give you 0. all right, or if you differentiate this constant, if you differentiate c as a constant, it's going to give you 0. all right, so that's why we have this imaginary c here. So just make sure you're always adding the c, because we don't know what the number could be. All right, that was a rhyme. So number 2, we have x plus 1 over x plus 1 over x. So let's do that. Now with the knowledge that you have, you can pause the video and see if you can attempt that. So you can just pause the video and see if you can attempt number 2. all right, so now the second question, x plus 1 over x, is basically the same thing. all right, only that this is a fraction. So now the easiest thing to do would be to convert it to indices. all right, so you don't want it to be in fraction, so it can actually have a power. So we're going to have x plus 1 over x will then turn to x to the power of negative 1. all right, by indices, x to the power of negative 1 is simply 1 over x. all right, so you're basically finding the integral of these two. Okay, so you're basically going to be doing the same thing. all right, so you have x here, so you're going to have, remember there is an imaginary 1 here, so that will be 1 plus 1, that will be 2, then divide by 2. Alright, now the ideal thing or the normal thing to do here would be x to the power of negative 1 plus 1. Alright, but obviously that's going to give you 0. But then you'd have to divide by 0. And obviously, anything divided by 0 is undefined, alright, and we don't want that. We want to have an actual answer. Okay, so remember that x to the power of negative 1, you can actually leave it as 1 over x. It's actually advisable that you leave it as 1 over x. The only time you should change it is if you have x to the power of 2, alright? But any power raised that is more than 1, so you can change it to x to the power of negative 2. That would be better. But since we already have 1 over x, alright, the integral of 1 over x is ln x. Okay, ln x, and this would be your answer. Alright, so like I said, leave it as 1 over x when you're finding the integral, unless you maybe have x to the power of 2 or x to the power of 3, basically x to the power of anything higher than 1. Alright, then you can turn it to this format, so you have like a power and you can add and divide and things like that. Alright, but because if we divide by 0, we're going to have an undefined term, we're going to leave it as 1 over x, integrate it as this, and we'll have ln x. So x squared over 2 plus ln x, and that'll be our answer. Okay, so I want you to pause the video and solve number 3. So remember, like I said, integration is the opposite of differentiation. So if you know the differentiation of trigonometric terms, alright, the integral of that would not be difficult. For number 3, we have negative cos x. So we have negative cos x plus the integral of 2x. Alright, so now when you have things like this, when you have like constant terms, it's preferable that you take it outside. Alright, outside of the integral sign. Alright, so we have a constant here, a constant term here, which is negative 1. So that will be negative 1. Alright, or you can just put the negative sign. It doesn't really matter. Instead of writing negative 1, you can just put negative sign. Alright, plus the integral of 2x. Okay, so now, like I said, if you have knowledge of the differentiation, then it would be very easy to solve questions like this if you have knowledge on the differentiation of trigonometric terms. Alright, so now you know that the derivative of sine x is cos x. Alright, derivative of sine x is cos x, so it means that the integral of cos x will be sine x because they are exactly opposites. Alright, so we're going to have negative sine, because the negative is already there, so negative sine x. Alright, remember, derivative of sine x is cos x, so the integral of cos x will be sine x. Alright, plus, you just solve this like we've been solving the others. So there's like an imaginary 1 here, so that will be 1 plus 1, so that will be 2, so that will be 2x squared, and don't forget to divide by power, so 2 would cancel out 2, so your answer is negative sine x plus x squared. Alright, and that's the answer for that. Okay, so I want you to pause the video, solve number 4, and yes, so you can know if you understand basically what we have been doing thus far. Okay, so for number 4, we have x to the power of 3 minus 3x to the power of 2 plus 2x plus 5, everything over x. Alright, so now the easiest thing to do would be to divide all the terms by x. Alright, and how we're going to do that is, okay, so this would be x to the power of 3 over x minus 3x squared over x plus 2x over x plus 5 over x. Alright, then this would be, x will cancel out this x, so that would be minus 3x. Alright, then this would be 2, x cancel out this x, then we have plus 5 over x. Alright, so if you find the integral of all of these, okay, that will be x to the power of, sure. Alright, so you have, let's get out the pen. Okay, so you add 1 to the power. Alright, that will be x to the power of 3. Then you divide by 3 minus 3, add 1 to the power, so that's 1 plus 1, that will be 2. Divided by 2. Then you have 2x. So there's like a 0 here because this is a constant. So 2x to the power of 0 is basically 2, because x to the power of 0, like we've discussed, is 1. Alright, so you basically just leave this as 2x, and then you have this. Now 5 over x can be written as, you can see this as 5 multiplied by 1 over x. All right, 5 multiplied by 1 over x. So we could basically remember that the integral of 1 over x is ln x. All right, and 5 is a constant, so we can basically say 5 ln x. We can write this as 5 ln x, and this would be your answer. All right, this would be your answer. All right, so now let's just solve number 5 while we're still here. Okay, so now the integral of sec squared x, like I said, it's good to have a knowledge on derivatives of trigonometric terms. All right, and the derivative of tan x is sec squared x, so it simply means that the derivative of the integral rather of sec squared x would be tan x. Okay, derivative of tan x, sec squared x, so the integral of sec squared x would be tan x. So tan x here is your answer. All right, so that's all for this video. In the next video we'll be talking about upper limits, upper and lower limits, okay, and some algebraic substitution methods, and more basically on integration, so we can have a full concept on it in this series.